on our real life. So, any questions regarding the course outline, regarding the syllabus, regarding the course structure, regarding how we are going to be proceeding with the whole plan for the upcoming months or registration, anything? If there is anything you want to ask, I'm giving you time because in that moment we can wait if somebody else wants to join in. Otherwise, we should then start off. So it's 9:02, giving you guys 1 minute. If there is any question, just drop them in the chat box. G Zulkarnain. You can just type in the message and मैं उसका भी जवाब दे देता हूँ. Okay, okay, perfect, perfect. That's great to know. You would be added to the registered students group if you have filled the form. So if you have filled the form, if you haven't, you can fill out the form, and our TA, there's no next step. Our TA is going to get in touch with you and she would add you to a separate registered students group. And great to know, Ramin. So you would be added to a separate group. If you are not added by now, don't worry. You would be added by like tomorrow, most probably. And even if not, then you guys should reach out to me. तो मैं उन्हें बता दूंगा, see? And then she would convey all the other details on what to do next. See? All right, so it's 9:03 and let's officially start off with where we left. So in yesterday class, we ended the discussion on how computers work. So we studied how computers are built up of circuits, and circuits could either be on or an off, right? So it has only two states, one or zero, one corresponding to on, zero corresponding to off. And then we saw how like a whole computer has multiple sort of components, and those components are again combinations of thousands and hundreds of circuits, and then each of those circuits could either be turned on or turned off at a specific instance, and the different sort of combination as of like one circuit being on and the other circuit being off could result in a different function. So continuing with that, the very last thing which we were discussing last night was binary. So we said that binary is basically the name of the language which computers understand. So if you are ever asked that what's the language computers are going to talk with, or like computer components used to communicate with each other, then it's basically binary. And in your books, once you start learning binary, the very first line, which usually teachers and a lot of people or the book or any course material teaches, that binary is a base two number system. See, so they say that, oh, I did not take the pen, my bad. So binary is a base two number system. But before discussing what base 2 means, we should go and discuss what does the number system term mean. So number system is basically a term which corresponds to how you can display a group of numbers. So it's like a format followed by a specific group to display numbers. So I can summarize it like, how can I display values or numbers? How can I display numbers? And why do we have to display numbers? Like for instance, if you get how, like without having numbers in our life, do you guys think you can calculate how much money do you have, or maybe how much score you got in a specific test, or maybe calculate how much marks you might be requiring in the other paper to get an A star, or maybe even like how much time would it be taking to travel from, let's say, Lahore to Islamabad? So all such questions or whatever actions we have at this point do include mathematics at some aspect, right? So for that reason, it's really important that the very first thing the computer has to understand is the word number system. Like how can a computer display numbers? Now, there are multiple methods in which a computer can display numbers. We're going to be discussing each of those methods. And one group of a method is basically known as number system. So like binary is one specific type of number system. Yes, Dulkanan, do you have a question? Guys, if you guys have any question, you should just drop them in the chat box. Yes. I would share the notes. Don't worry, don't worry. And apart from that, I personally would recommend that if there is something which I tell you guys that this is important and should be memorized, you should just write that down. Otherwise, during the class, I would recommend that you guys just focus on the class content. And once you start doing those topical, these content and stuffs are automatically going to be memorized. Just make sure that you get the concept at this point. So, yeah, so no need to make notes. I will be sharing this whole document with you guys, and you guys could just go over that later on. Yes, we would be having a class inshallah tomorrow too at the same 9 to 10 p.m. Time period. So, yes, so now coming back to the original discussion, so we said that number system is basically a method of how a computer can display numbers. Now, this means that the computer can display numbers in different ways, right? So we have three main ways which we are going to be studying over the coming class time. Say, so we have three main number systems, perhaps. Ahmed, we won't be able to do that because we have other subjects classes at other times. So, due to a clash possibility, we only have 9 to 10 p.m. as the only possibility. And I cannot do it earlier on because I also have my university. And if I do it after 9, that would pretty much get very late. So, keeping all those factors in mind, 9 seems to be the most suitable time. Coming back to the original discussion, so when you were going through the book, or maybe if you were ever revising this topic in school with your teacher, they might have mentioned that binary is a base 2 number system. Now, people memorize. People just go and learn that okay, binary is base 2 number system. They never understand what do we basically mean by the term base 2, or what does it tell us about something. So, like if I say binary is base 2, what does that mean? The term base 2 basically means that it has two possible values. Okay, two possible values. And in yesterday's class, we saw how computers, or in other words, binary, only have the state of 0 and 1, right? So whenever we are going to be writing any value, any number, anything in binary, it always has to have the value of either 0 and 1. So I can speak in like zeros and ones, and it's going to be counted as binary 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, and so on. So this type of language which I'm speaking right now, that's binary. And we call it binary as base 2 because it has two possible values. But now you tell me, have you guys ever talked to each other in binary? Like, have you guys, if I tell you, bro, tell me, Sulkanan, tell me how many marks you got in your last test. So have you ever told me the marks as in 0, 1, 0, 0, 1, 0? No, right? You guys directly say like 9 out of 10, 8 out of 10, 7, 6, 5, 4, and so on, right? Now, what's that? The number system which we conventionally use, the conventional number system, let's call it that way, the conventional number system is basically the conventional number system. Just the way we gave the 0 and 1 number system the name of binary, the conventional number system is basically known as denary. Okay, so it's known as denary. You just need to keep the name denary in your mind. And denary, yes, the class is being recorded. It will be uploaded later on our YouTube channel too. So when we say that denary, that word denary basically means that we are talking about a number system which basically includes the values which we conventionally speak of. So what are those values which we usually bring in when we are talking with each other? It is basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after that, definitely the same value is being repeated. Like if I say 11, it is basically 1 and 1. But the 1 originally does come under the original list between 0 to 9. So remember that in your book, if you're revising the content, they will be saying that denary is a base 10 number system. Okay, base 10 number system. When they say it's a base 10 number system, this means that it has what? It has 10 possible values. And what are those 10 possible values? Those 10 possible values are not from 1 to 10. They are basically from 0 to 9. So it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I want to make multiple combinations like 787, then this is again denary. Why? Because we are basically treating each digit separately. So in one box, it's like 7. Then in the other box, it's like 8. And then again in the third box, it's like 7. You do not have any possibility where a single box, let's say if I say that this single block is storing some value, or it might be a block or within the memory which can store a specific value. So we must say that this one block is only going to be containing a value between 0 to 9. It cannot have a value like 13. That's not possible. At least for Denary, that's not possible. So the second number system which you all have to know is basically Denary. So in your exams, you might be given a question as to, let's say there is a specific Denary value, base 10 number, or the value which we usually understand, like 18. Okay. And then it might tell you that, bro, can you please convert this into the language which the computers understand? And then you have to convert between the conventional number system or the denary number system all the way to binary. And just like that, once you learn that, you will also be learning how you can convert a binary number system or a binary value back to conventional number system, which is denary. So these are two of the three number systems which you guys should be aware of. The third one would be discussed later on once we cover up all this discussion in great depth. Now, before moving on, I want all of you guys to either tell me if anything is unclear, or otherwise just spam the chat box with the word clear, which would mean that you all understood what binary means, what denary means, what's the logic behind base, and what's the logic behind having the value after the term base, so like base 10, base 2. And if I say, let's say I have a question for you guys. If I say that there is a specific number system which has base 18, let's say I just made it up. If I say a number system has base 18, what does that mean? In the chat box, quickly. Perfect, great to know. Jaldi, jaldi, jaldi. What does base 18 mean? Based on the logic which I just told you. This won't be tested, by the way, but this is something I just wanted to ask, just to see if you guys are getting it or not. Exactly, Samraj. Perfect. If I say that a number system has base 18, this basically means that it can have 18 possible values. But in our course, you won't be tested on such extreme cases. You should be just aware of binary, which is base 2, having two possible values of 0 and 1. Denary, which is basically base 10, having the values of basically having 10 possible values all the way from 0 to 9. And then there is this one third base, which number system, which we are later on going to be studying on. That's known as hexadecimal. And that is basically base 16. So you don't need to get worried about hexadecimal and how we're going to be catering with that. We are going to look into that later on. For now, our today's class discussion would be basically regarding how you can convert denary into binary. So denary into binary, or in simple words, if I tell you, bro, you scored 8 out of 10, right? I want you to convert this into the format which the computer can understand. Now automatically when you like type in the word letter 8, like if I'm writing 8 right now on my keyboard and I'm sending the message just the way I sent it in the chat box, I wrote the value 8. But when I pressed the 8, the computer translated that 8 into binary, and then it basically sent the binary value throughout the whole system, did all the execution, and later on when it was received at your computer's end, it basically reconverted it back into the denary form. And so on your screen you now see the denary digit 8 rather than some zeros and ones. But now we need to study what did the denary 8 value originally converted into when we were talking about binary. Say, so now we need to study the conversion. Now, to do that, you need to first of all understand that if I say there is this one digit number 1256. Now, if you guys remember back in primary school, like when we were really young, grade 1, or maybe even in Montessori, they used to teach us the value of position. So we used to say that this is ones, this is tens, this was hundredth position, and this used to be like thousands. Say, so we used to say that we have 1000, say, we have 200s, say, we have 5 10s, and we have 6 1s. Remember, we used to study something like this back then. Now, what does this hundred, thousands, tens, and ones indicate? They basically tell us the position, right? So it tells us that at the 100 position, if there is 2, this basically means that starting from the most right, if I go to the third element, which is basically for the 100th part, it is going to be having the value 2. And this indicates the importance of values, right? Or the position. So remember, when we are dealing with computers, binaries and numbers in computers, we also have to look for position. Now, before learning how to convert between binary to denary, you need to understand that if I tell the computer some specific value, do you guys think that the computer has some sort of brain or maybe a register with themselves where they can write it? Or is it like I just input it and it automatically just goes on and then vanishes? What do you guys think? The thing is that if I want the computer to, okay, Zulkarnain is saying it's programmed. Okay, I get that it is programmed, but definitely if I tell you that, bro, let's say for instance, am a perfect register, right? So if I say that I tell you a specific number 787, and I tell you that you need to tell me the exact same digit after a week, what are you guys going to do? You will be writing it on your notebook, right? And by writing it in your notebook, or maybe by memorizing the digit, it's basically going to go and it's going to get stored in your memory. So just like that, whenever we are going to input some specific value to the computer, it is going to go and it will be stored in specific memory slot. So how does a specific digit get stored in a memory slot? So in your computers, what happens is that we have basically boxes like this. We have such large boxes, and they have like special, you can say, what do we call it? I can call them like boxes. Say, so we can have like 8 boxes: one, two, three, four, five, six, seven, and eight. So it's not compulsory that it has to be 8 boxes, but let's say we make 8 boxes in it. This one whole slab which I just made with small 8 boxes in it is basically what we call as a register. So a register is basically that component of your computer which stores some sort of value. So if I say that there is some binary value or whatever files you have or whatever, like if you open up your not browser, if you open up your hard disk and if you see the back end programming of the hard disk, it is basically that every specific thingy within stored within your hard disk is stored in some sort of register. Say yes, Zarak, you're right, but we are coming to your point in a while. Say so now everything which your computers are going to store are basically going to be stored in a register. An example could be that if, for instance, you go to a library and then you borrow like 100 books, you guys think you're just going to be, and you just like bring them to your home. Do you guys think you're going to put it in the kitchen? No, right? You will be taking them to your room, and in your room, you might have a shelf like this. And onto that shelf, you might say that, okay, I have special boxes made up and I'm going to be storing the books in there. So, like if I have 3 books, one book could go up here, so like a large sort of book. Okay, so a big book come up here, another book can come up here, and then maybe one book could go up here, right? Now you see that one specific type of book is being stored at one specific box. And the same concept applies to registers. So like if I say that there is a binary value of, let's say, 0100, then this 0100 would be separately stored up here. So like it can go like 0100, maybe 1000. Okay. So every box within that specific register is basically going to be storing a specific binary value. So the purpose behind telling you this is that it's always whenever you're going to be doing a question related to binary conversion or registers, remember that there will never be any possibility in your course where you can write a 10 within a single box. That's not possible. One box can only contain one specific binary value, and we have only two possible states, right? So it could be either a 1 or a 0. And within the register, we can only store binary values. So these are some important points. Why can we only store binary? Because definitely, if I have to, like for instance, if you have to write the 786 number, which I just told you, because you need to tell it to me later on, and you are going to be writing it on your notebook, definitely you're going to be writing it in a way which is the most easiest to use. So yes, so like if I give you guys a big paragraph and you are comfortable in writing the whole paragraph in English, definitely you're going to be writing it in English in comparison to, let's say, Urdu, which might be difficult for you, for example. Say so if it's, you guys have to write it in a way which is the most feasible for you. All right, so computers operate in the same way because binary is the actual language through which it can communicate with each other in the least possible time, in the most fastest way. Computers are always going to convert whatever your value, whatever your file is, into a binary form, and is then going to store that binary form in a specific register. And register is basically those shelves where you can store values. Now, is registers clear? Quickly in the chat box, is registers clear? Yes or no? Perfect, good. बाकी भी जल्दी जल्दी. Great. बाकी भी बताओ. Ahmed, Inaya, Zarak, everybody. Saifullah. Great, great, great. That's great to know. Okay, okay. Say. So, Coming to this one point, if you now count these boxes, how many boxes do we have? We have one box, two, three, four, five, six, seven, eight. We have eight boxes. Now, how can I tell a person that I'm storing these values in like a eight box register? To do that, and I am coming to your point. No, no, I'm coming to your point. Wait. Now, if I have to basically tell some specific person that we have eight boxes, what type of, like, I just can't say, like, bro, are you storing the value in the register which has eight boxes? Isn't that something which might seem a bit vague? Because definitely computer science, we are the cool people, right? So the computer scientists or the computer science students who are studying computer science, you guys are cool. So you can't go with the normal sort of language which normal people might be using. You guys have to use the specific CS related vocabulary. So if I have to denote that we have eight number of boxes, we basically do it in a way that we say that we have an 8-bit register. 8-bit register. This also means that each of this one binary digit, a 0 or a 1, is basically 1 bit. This also means that one box can basically store 1 bit. So if I give you guys a register which has like the maximum capacity of 12 bits, what does this mean? This means that it can maximum store 12 bits, right? And because one box can store only 1 bit, this means that that register has 12 possible values. So 12 boxes. So if this is like an 8-bit register, we might have like a 12-bit register like this, which might have like 12 possible value, 12 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and maybe a 12. So this is like a 12-bit register. Why? Because it can now store 12 separate bits, and one binary value basically occupies 1 bit. So ये भी जहन में याद रखना. But now in your course, most of the time whenever we are going to be dealing with binary related questions, the most common way of answering any question would be in an 8-bit register. If it is of 12-bit or maybe smaller, they will be giving you guys a specific sort of keyword in the question. So they might say that a register of 12 bits is being used, or a register of 16 bits is being used, or a register of 4 bits is being used. But if it's not given, you guys should assume that we are dealing with an 8-bit register, which also means that whenever you're trying to give an answer in a, or write a register value, we would be doing it in an 8-bit register way. Now, this one whole, बल्कि उस पे बाद में आते हैं, या भी नहीं करते. Now we have this one register, right? अब register की तो समझ आ गई, that register basically stores binary values. Now coming back to the actual question which we were dealing with, we had denary value and we need to now convert it into binary. Now just the way we have like these ones, tens, hundreds, and thousands as specific values for the position. So like we have this as position number 1, right? So any value at position number 1 is basically going to be multiplied by 1 because this is the 1 position. Then this is position number 2, this is position number 3, and finally this is position number 4. Now each of these positions have a different value. See, this is 1, 10, 100, and 1000. The computer register also operates in a pretty similar way. So if I have a specific box up here, if I could somehow copy the same box because it was made in the right way, let me try. I hope it gets copied. Control C and Control V. हो गया? नहीं हुआ. एक second. Let me redo it. Because it does get copied sometimes, but I don't know why not. So if I have this specific copy and I want to paste it up here. Oh, yes, it's up here. All right, so let me bring this down here. Okay, so if I have this specific register once again, let me remove these highlighted parts and these values. The important point here to note is that all of these separate boxes have a different value. So just the way we had a 1, 1000, 100, or maybe even 10, the binary register also operates in a pretty similar way. So every box which exists up here has a specific value. Now, remember, in computer science, it always starts from, just like the normal numbers, it always starts from right and goes towards the left. So like the first element is going to exist at this point. This is our first position. And this is going to be my last position. Now, one other important point here to note is that usually if I tell you that, bro, count how many chairs do we have in a classroom, You all are going to start from the number one, right? So you would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But remember, this is very crucial. This is really important. No, no, it cannot go from there. It's the same way, bro. If I tell you you have a number 1234, have you ever read the value like 4321? Have you ever went this way? No, right? You always go from left to right in the conventional number system. But remember, if I have to deal with binary, I will be going from right to left. So it has to be the other way around, especially when I have to write values. And also in the conventional number system, if I have to basically sort of write the first digit, मुझे एक बात बताओ, if I have to write the smallest value digit, which among these four has to be the smallest one? This is the most smallest one, right? The ones while apart. This is just 4. This might become like 34. This would be like if I write 2, this becomes 234. And if I write this 1 with it, this basically makes it 1234. So basically, my most smallest value is this 4, right? So just like that, whenever we are trying to fill up a specific register, we always go from the most right hand side and go towards the left. Why? Because the most right hand side is basically going to be storing the most smallest value. So we start from the ones and slowly increase based upon the value. But now coming to the point where Zulkarnain, you're saying 1, no, 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 it's not like that. So remember, if I just tell you that what's the position of this specific box, all of you would be saying that, sir, this is the first position. So just the way you told up here that we have this as ones, this would also be having the position 1, right? But this is something which is different for computers. In computer science, let me write it up here. In computer science, the first position is not 1, it's 0. Because we are aware that computers are going to be understanding 1, 2, 3, 4, 5, 6 as in Denary, right? Denary number system. And we are also aware that Denary number system basically begins from what? It goes from 0 to 9. So it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for computers, the very first element is basically going to be 0, which means that the position of the most right hand side register bit will be a 0. So this is position number 0. Then this becomes position number 1. This becomes position number 2. This becomes position number 3, 4, 5, 6, and 7. Now it may seem like we have 7 positions, but we also have to include this 0, which means if I count from 0 to 7, we have those 8 bits, which we already mentioned up here, 8-bit register. So yeah, now if I know the position, this is really important because even aage bhi jaake when we are going to be doing the programming related questions, if there is something stored within a specific memory slot and I have to access it, the first element, unless I define it the other way around, the first element is always going to be 0. So for all the questions which we are going to be doing in chapter 1 or in the theoretical part of CSP1, we will be taking the first element to be 0. So if I say, let's say that Ramin, you scored you have the position 0 in the whole class, and you don't need to worry. This does not mean that you are literally at the bottom of the class. This in other words mean that you are at number 1 position. And if I, let's say Ahmed, you are number 1 in the class, this doesn't mean that you might be number 1. This might mean that you are on position 2. Why now? I know this might seem confusing, right? But for computers 0 is the number 1. So because computers understand it in a way like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for us, we usually ignore 0, right? We started from 1, but computers cannot ignore 0. They don't have the mind which we have, right? So conventionally, it has always been operating in a way where 0 was termed to be the first element. So remember, 0 is my first element. So for this reason, if I ever say that one of you is basically ranked 0 in the whole class, this basically means that you would be ranked number 1 in the whole class. And do keep this in your mind because I might give you some scenario where I might say that you are ranked this much in the whole class. So be aware of that. See? So now, before moving on, I want you all to let me know, is this position wali baat clear that what do we mean by the most right hand side to be 0? And how did we get this 0 and why did we get this 0? And this whole register thingy which I mentioned earlier beforehand. That's great to know, Zulkanan. That's the way you have to go and prepare for the zero position now. Not for zero marks, though, zero position. Okay, perfect. That's great to know. Bakibi, if there is any question or anything which you guys do not understand at any point, just ask questions because I really appreciate when students ask questions. And it's not that that's so great to know, Inaya. That's such a great score and wonderful score. Congratulations. But still, I would now recommend that if you have any questions or you do not get anything, directly ask the question. There is nothing like a wrong question. सही है और डोंट वरी जुल्कनैन अपकमिंग मॉक्स में देख लेना you're going to be the highest achiever in your class inshallah don't worry see you just need to understand the concept so like even at this point you all have studied CS at some point right have you ever understood the logic behind why something is called base, or maybe what's the logic behind register, or why does a computer constitute the first position to be zero and not one? These are those small tips which really make up the concept, and people usually miss them. So, my personal advice will be do not miss such stuff and do keep them in your mind so that your concepts are clear, right? So, now coming back to where we were, अब हमने ये देख लिया कि we have multiple positions. Now, at this point, the way we had like zero, one, tens, hundreds, and thousands. Now, each of these positions which we have up here, all the way from 0 till 7, they have a specific value. See? So the formula for value, like a lot of times people when they start learning computer science, they're usually given this formula, not a formula, they're just told that bro, aapne ye yaad karna hai. And what values? The values which Inaya stated earlier on, 1, 2, 4, 8, 16, 32, 61. Now, but definitely if you haven't studied computer science, you might be thinking, bro, how will I be memorizing that? That's so difficult. So for you all, I came up with this equation. It's not there in the book. It's not there in some sort of document. It's something which I created on my own for you all ease, and it is basically value of that specific slot. Of that specific slot, value is basically equal to the base of the number system raised to power the position. Say, so in this case, we all are aware that we are dealing with binary, right? We are storing zeros and ones in these registers, just the way we did up here. So if I have to convert a specific Denary value into binary, this means that I want my base to be what? I want my base to be what? Coming to your question, Ahmed, just a minute. What base are we going to be dealing with up here? Quickly, guys. Zero? No, 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 no. Base, not the position. If I'm converting something from denary to binary, this means I want my final answer to be in what base? In a base 2 number system. Exactly, Samraj. Bilkul Zulkarnain. Perfect. We want our final answer to be in base 2 number system because we want our answer to be in binary, right? So we want the base up here to be 2. So while using this equation, I would be like, okay, base, oh, so I would be like, let's say if I want to find the value for position number 1, value for, let's say, position 1. So ये वैसी में P1 लिख रहा हूँ. This isn't something जो कि आप लोगों ने करना है, and over time these values are something जो कि आपको याद हो जाएंगे. Why वो मैं आपको बता दूँ. But the value of the very first position is going to be 2 raised to power 1, the position. Now we know that the position of the first bit is not 1. It's what? It's 0. So the value of the very first bit will be 1, which means मेरी पहले इसकी value क्या आ गई? This is having a value 1. Now, second box की क्या value होगी? I'm going to explain what's the importance of these values, but अभी second box की क्या आएगी? What do you guys think? You guys sure 2 power 1 is 2? Perfect, Zarek and Ramin, you guys. Inaya, perfect. Because if I re-plug in the position from all the way from 0, no, it's not multiply, bro. It's raised to power. So it's 2 raised to power 0. It's not 2 multiply by 0. There's a difference between multiplication and raised to power. If you take up your calculator and you do 2 raised to power 0, it won't be 0. 2 raised to power 0 is basically 1. This is one mathematical property which you're going to learn. So 2 raised to power is always 2 raised to power 0 is always 1. It's not 0. Say so because of that, we're going to be having the second position value to be 2 raised to power 1. Just like that, 2 raised to power 2 is now going to be 4. 2 raised to power 3 is going to be 8. 2 raised to power 4 is basically going to be 16. Until now, you might have observed the pattern that basically it's the double of the previous value. So 1 into 2, 2 into 4, then double, then double. And so the same concept applies that the next value is also going to get double. So it's going to be 32, 16 ka double ho gaya. And then the sixth slot is going to have, or perhaps this will be the seventh position. This would be having the value 64. Why? Because it's the double of 32. And just like that, the last bit is going to be having the value of 128. See? So it's just getting multiplied. Now, when we have all this, bilkul perfect. Now, just a minute, let me ask the question which Ahmed said that from Thursday my exams are starting. My CS is on next Friday because of other I cannot take tomorrow. Acha, Ahmed, you don't need to worry because the recording would be uploaded on our YouTube channel, so you can watch the recording aram se. And if there is anything which you feel like कि आपको सही तरीके से समझ नहीं आया, you can always reach out to me on my WhatsApp number and we could have a discussion on it. So yes, so you don't need to worry. If you have your mid starting off, if you have any of your quizzes coming up, you can watch the recording later on. And if there is anything that you feel like is not clear, you should always just message me. These recordings are only shared, or these specific recording which I'm currently uploading on my YouTube channel, these are only going to be of the demo classes. So like from this Friday till this Friday, so like Monday, Tuesday, Wednesday, Thursday, Friday, these 5 classes are going to be uploaded on our YouTube channel, and starting from the next Monday, none of the classes would be uploaded. So they would be only available to the students who have registered for the course. So like the recordings which are currently being posted, these are only of the demo classes. Say, do the Denary number system include negatives? Yes, they do include negatives. We would be coming to that after a while, like inshallah, after 2-3 classes. So yes, so don't worry, we are going to be dealing with negative values too. But at this point, we are only dealing with positive values. Now coming back to the whole actual scenario, अब हमने ये तो देख लिया that each of these slots have a specific value. Now let's forget these positions. So let me erase, oh, छोटा कर दो इसको. Let me erase the 7, 6, 5, 4, 3, 2, and 1, right? Now, if I give you guys a specific number, if I give you guys a specific number, let's say I have the value of, let me recopy this because I would love copying the stuff and writing it neatly beneath. So let me just copy this, कहाँ से होता है? This and duplicate. कहाँ से होता है? This duplicate, this is duplicate. Oh, copy. I hope it gets spaced. Oh yes, let's go. So we have this register with us right now. And if the question right now comes up out of nowhere and it says that, bro, let's say one of you scored 56 out of 70 or 60. Say, I want this 56, which is basically in a base 10 number system, or is a denary value 56. I want to convert this into binary. How will you be converting a 56 denary value into binary? So the logic behind what you all are going to be doing is we have to basically put one under all those values when I later on add up, it is going to get me 56. What do I mean by this? I mean that if I have these 8 boxes with me, I have to put one under all those values, which when I later on add them, I should be getting the answer 56. Let's do an example. Let's do this example. फिर समझ आ जाएगी. So definitely, I cannot put a 1 under a value which is greater than 56, because how is it possible that 64 plus some positive number is going to get me a 56? That's not possible, right? Because we do not have any value of negative up here, right? If there was something like negative 16, पे तो possible होता, but it's not possible at this point. This means that we cannot put 1 under any of those things. So जिन चीजों के under हम 1 नहीं करेंगे, we're going to be putting a 0 beneath them. So a 0 beneath 128, a 0 beneath 64. Then definitely, if I say that I need to get the value of 56, I can put a 1 under 32, right? Because 32 plus something would get me 56. Now I need to put 1 under all those values, which when I add into 32, I would be getting 56. Can I put a 1 under 16? What do you guys think? Yes, I can. Yes, I can, Zulkanan. I can. Why? Because tell me one thing. If I do 32 plus 16, what will I be getting? I would be getting a 48, right? Which means that if I put a 1 under this too, what other thing would I be adding into 48 to get a 56? I cannot put a 1 under a value which if I add into the previous values, I would be getting a value greater than 56. I know it's a bit confusing. Chapter number 1 has to be the most boring concept out there, but you don't need to worry. So yeah, it's something जो कि आप एक दफा understand कर लो तो आपको समझ आ जाएगी. Now, Just a minute, Ahmed. So, guys, let me know if I have to find 56, what other thingy would I be adding into 48 to get a 56? It would be 8, right? So, if I add 48 and 8 together, I get 56, which means that now I need to put 1 under all those values, which could get me an 8. Now, I can only put 1 under this because definitely that's directly going to get me an 8. And now, if I add 32 plus 16 plus 8, what value do I get? I get a perfect 56, which is the exact Denary value which I had up here, right? So this means that if I put a 1 under any of these other values, this is going to get me a value other than 56. So for that reason, I'm going to be putting a 0 up there. And so this means that the binary value for the Denary 56 is basically 00111000, which is 100% identical to what Ahmed sent in the chat. Perfect, Ahmed. Bilkul, you were 100% correct. Walaikum assalam, Ahmed Aman. I hope you're doing well. No worries, man. We are currently doing chapter number 1, conversion into a binary and denary number system. If you haven't watched this yesterday class, I can share the recording. You can watch that and can later on watch the recording of this class too, and can then continue with this from tomorrow's. Say so, Abhi, if you do not get the concept which we are discussing right now, you can also go watch the previous recording. We had just a general course outline being discussed there, nothing special, but still, that's great to know. See, that's great to know. If it was stored in your mind somewhere like 2 years ago, still that's great to know. So let me just send you guys my channels, and in the channel I have a specific new playlist with the specific name of new written with it, chapter 1, uh, data representation new. So you guys have to watch that one. It basically includes the demo classes. So now coming back to the concept, now the binary of the value 56, Walid, yes, hold on. So if the binary for a specific Denary value 56 is basically this 00111100. So what steps did I follow? So now this is something you guys might be looking for. Number one, I have to basically put one under all the values, under all values, which when added, which when added will get me the Denary value. Get me the Denary value. Denary value. And step number 2 is that basically put 0 in all the other boxes. Put 0 in all the other boxes. All the other boxes. This also means, and an important point here is that whenever we are dealing with registers or binaries, the main value holding thingy is 1. So if I say that a specific box has the value 1, this means it has some sort of power because it is having a specific value. But if a box has the value 0, this means that it is of no use. It is just to be ignored. Say this also means that if I have a 0 up here और मैं यहाँ पे एक और 0 add कर देता हूँ, इससे कोई मेरे आंसर पे फर्क नहीं पड़ना. Why? Because 0 has no value. If I have like this 128 doesn't stop up here. If I have like a 12-bit register, if I have a 12-bit, like I have 12 boxes, definitely I have 4 more boxes at this side too. So this has to like get multiplied. It will become 256, then it's going to continue and it's going to go on. So like the one you might have seen like 64-bit, like when you were making your processor, you might have heard the word, this is a 64-bit Windows install on your computer or a 64-bit processor. What do we mean by those 64 bits? Those 64 bits are basically talking about these registers that the way we have right now as an 8-bit register. Imagine 8, then 12, 16. So we have a 64-bit register which can basically at one point store 64 different sort of bits. समझ गए? So इस तरीके से you have multiple sort of registers within your computer, and if a specific box within or a specific slot within your register have the value of 0, it has no value. So even if I add like 100 zeros towards the left, it won't make any difference. But I cannot add zeros on the right side. Why? Because definitely this 0 is my starting position, right? So आप मुझे एक बात बताओ, if I say that a race is starting from this point, the point where I have my finger right now, and it's going to go to this side. Is it possible somehow that that a specific person is running from this part, given that I have a wall up here? No, right? We're going to be starting from the actual starting place, which is the real point, or the first position in the whole of the register, right? So it's what I say, if you ever see a question where you have useless number of zeros, redundant zeros, repeating zeros towards the left hand side, it's just there to be ignored. उससे कोई फर्क नहीं पड़ता. हाँ, if I say that you have something like a 0, 0, 0, or maybe it goes on, and then you have a 1. Now, this does have some meaning. Why? Because this means that if this had the value 32, this 0 had a value 64. See, then this 0 had a value 128. This first 0 is going to have the value 256. This 0 will be having 512. It won't be of any use. But this one will be having the value 1024. And because it has 1 beneath it, we will be adding that into it too. So if I say that I wanted to find the binary for like 1024 plus 56, it's going to come up as 0 and 1. 8. So if I had to find the Denary binary value for the Denary number 1080, it would have been basically 10000 111 But now if I count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I have like 11 bits. So our registers usually are in a group of 4. So it can be like 8-bit register, 12-bit register, 4-bit register, 16-bit register. But at this point, you might be saying, and you would be thinking, sir, we have 11 bits. So if I have to store them in like a big box like this, I have like a 12-bit register. Wow. Yeah, let's make it neatly. So I have like a big 12-bit register like this. Yep. And now let's make 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. See, now if I have to mention this specific binary within this register, how will I be doing it? Would we be starting from the most left hand side, or would we be going from the most right hand side? So remember, whenever you have to write binary, perfect Zulkarnain. Whenever we have to write binary, we always go from the starting position to the ending. Like aap race laga rahe ho, you are in a marathon. Have you ever heard the story where someone might be going from the ending position towards the starting? No, right? It's always from the starting position to the ending position. So because our register starts at this point, this is my start, the binary would also be filled from this point. So like if I have to copy this specific binary value into this, ye kaise hoga? We're just going to be copying it from the most right hand side. So the 0 is going to come up here, followed by another 0, then another 0, then we have 3 ones, 1, 1, 1, then we have 1, 2, 3, 4, 4 zeros, 1, 2, 3, 4 zeros. These are the okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Okay, say, and then we have 1 up here. Say. So you see that we have one empty box left. Now, if in an exam they give you a question like this, and wo aapko bole, now you might be wondering, sir, mera jo answer tha, that was maximum up to 1. Now, what will I be doing? So remember, if you are in a scenario like this, you can always put one extra 0, because we are well aware that this 0 has no value, right? So even if this is like having the value 2048, until or unless we don't have 1 beneath it, this 2048 holds no value. And how am I getting this 2048? It's basically that the previous one is 1024, it's the double of that. Or we can also do it the other way around. If I do like 2 raised to power what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I do 2 raised to power 11, it's also going to get me 2048. But you cannot do this the whole time. So just know the previous value ko multiply kare. So like this 1024 got up from 512. That got from 256, and this 256 was from 128, and 128 was from 64. So like 128, 256, and then 512, 1024, and 2048. So if I have to demonstrate a specific value within a larger register, remember, you're going to be starting from the most right hand side towards left hand side, and if there is empty boxes, add zeros into empty boxes. This is again something very important, because usually people are not aware of this, because zeros do not make any change. Samajh gaye? Yes sir, perfect. Now this is how you are basically going to be converting denary values into binary. Now there is one other method too. which has been discussed in your book, which is the LCM method. So if you ever were studying from a teacher in your school or college, or you were reading the book or maybe watching some YouTube channel, you might have seen the LCM method. But I personally would not be teaching you guys the right method. Why? Because in your exam, they can never specify that, bro, you need to make use of the LCM method or this method. Now, the LCM method is the one where you have to consecutively divide the value by 2 again and again, and you have to look at the remainder. And remember, you do not have the opportunity to use a calculator because the calculator is not allowed in your exam. So the chances of making an error, especially like when I was studying computer science back when I was giving the exam, I hated that method. I could not do it rightly us side se. Sahi hai? For that reason, I came up with this method, which I personally love. So like I am easily going to be using this method, and it's going to be getting me the right answer. Say bilkul zara, perfect. You cannot divide those big numbers. That's like a pretty big mess, right? So this method has to be the easiest. You just have to look up what values beneath which can I put one should I look for, so that when I add all of them, it's going to get me the answer 56. And remember, just like that, in our course, we will be looking towards shortcuts. So we are going to be understanding the concepts and we'll be going through that specific way, which would get us the answer in the least possible way without spending our brain power. So look forward for these shortcuts. And these are the exact shortcuts which I was talking about in the first class, that we are aiming for the distinction. So if we are aiming for distinction, this means we need to minimize our chances of errors. So yeah, no, LCM is easy, but then you tell me one thing. If I have to, like, let's say, find the LCM of like the value 237. So the chances of making an error is really high, that you do 2 say divide kar, okay, kya banega, and then you're separately making math that 237, okay, 2, and then you're dividing them. What if you make a mistake? तो वो काफी मसला हो सकता है. But in this scenario, it's like literally easy. Okay, so it's 237. Let's do 237 ka. Let's do 237 ka now. Because it came up, let's do it. 237. Okay, let's write the value. So this is 128. This means इससे पिछला वाला, this would have been 64, 32, 16, 8, 4, 2, and 1, right? So let's remove all these ones and zeros. So let's remove them. And how will we be doing this? Now, firstly, the one another tip which I would like to give you all is that if I have this specific 237, why from right to left? Okay, explain karta hu. But don't worry. We're going to be going from right to left because we always go from the start position to the end position. So you tell me one thing: if you are in a marathon and you're race running, would you be running from the starting position towards the end position, or would you be going from the end position to the starting position? Emma, tell me this. You would be definitely going from the starting position, right? Jahan se race start hui hai, you're going to be running from that point and you're going to go towards the end. Just like that, because we know that the starting position is one. What's the first position? We already said that, right? That the first position is this most right hand side box, right? This is the first, this has the position 0, which we mentioned up here. See, this had the position number. Kidhar gaya? Oh, I removed them, but I said that this is my box number 0. Kidhar maine kiya tha? कहीं किया तो था. Never mind. Yeah, see, position number 0. This is my starting one. So we always have this as my first position. This is box 0, 1, 2, 3, 4, 5, 6, 7. So whenever I have to basically fill a specific register, I will be filling it from the most right hand side, and then we'll be moving towards the left hand side. See? So now we are now going to be doing the question where I have the denary value 237 and I need to convert this into binary. अब मैं करूँगा कि I will be making so like in exam they might give you a working space, and so you should just write these values, make some small boxes if you can, and over time आप लोग के improvement होता जाएगी and you will no longer be requiring these boxes either. But now if I have to write this, I will be firstly putting one under a value which is less than 237, right? Because tell me, is there any possibility कि मैं 512 plus something करूं which can get me like a 237? Given that we don't have any negative numbers up here, it's not possible, right? So this means that if there is a value which is greater than 237, वो तो automatically ही 0 हो जाएगी. That's automatically going to become a 0. Yes, Zulkarnain, which means that 2048 is going to be 0, 1024 is going to be 0, 512 is going to be 0, 256 also, because it's greater than 237, that is also going to be 0. तो पहले चार तो easy easy zeros हो गए. Yes, Zulkarnain, do you have a question? You can just send it in the chat box. अब जब हमारे पहले चार zeros हो गए, don't we need an 8-bit register for this number? Okay. Now that's a good question, Zulkarnain. That's a pretty good question. Now this value could be stored in an 8-bit register, but what if I give you a 12-bit register? No change in the answer. We are just adding these extra zeros. You see, 0, 0, 0, 0. They won't make any difference. We're just adding useless zeros. So the same point which I was just mentioning earlier on, if I have an 8-bit register and I add useless zeros at the back side, it won't change the answer, right? So the same thing is applied up here. I have a 12-bit register right now in front of me, and let's say I have to store a smaller value in it. How will I be doing it? I will be turning on all the ones beneath the value, which when I add them, it's going to get me a 237. And in all the other values of whatever, like it's 12 right now, even if I make it 16-bit, all the extra boxes which I have towards left, they will be filled with zero, because zero does not have any value in computers. We just ignore them. So even if I add like useless zeros, उससे कोई फर्क नहीं पड़ता. समझ गए? So for that reason, it's not necessary that you need to have an 8-bit register. Usually if the question does not specify कि यार you have to give the answer in 12-bit or 16 bits, then it's recommended that you should give the answer always in an 8-bit register. But because we have a 12-bit register made up at this point, we will be just filling this out. See? So now 128 is definitely less than 237, which means I can put a 1 up here. Now this means that I'll need to now put 1 under all those values, which when I add into 128 should get me a 237. So अब मैं और कौन सी चीजों को 1 करूंगा? I need to basically do subtraction for that. So 237 से मैं 120 subtract करूँ, this is going to become 2, this is going to become 17. So 2 plus 7, 9. This would be 0 and 1. So I need to now put 1 under all those values, which will get me 109. अब 109 से 64 तो बड़ा है. Okay, 64 done. 32 2. So 64 plus 32 is what? It's 96. Okay, makes sense. So now let's subtract 109 से 96. This is just for your own practice. या हम directly addition से भी कर सकते हैं. But if you want to do it through an easier way, so मैं subtract कर रहा हूँ. 9 minus 6 is 3. 0 1, and this is 1. This means I need to now put 1 in all those places, which when I add up I should be getting 13. So should I put a 1 up here? No. Why? Because 13 is smaller than 16, so this would be a 0. 8, yes, 8 plus 4 is going to get me a 12, and 12 plus 1 is going to get me a 13. So now I will be putting a 0 in all the other boxes. And now if I add all of them, so 128 plus 64 plus 32 plus 8 plus 4 plus 1, you will see that I would be getting a perfect 237. Like, let's do it on the calculator. Say so. Just a minute. मैं आपको calculator पे कर देता हूँ. 128 plus 64 plus 32 plus 8 plus 4 plus 1. You see, I get a perfect 237. I hope it's visible. Yeah. So you see 237. Yes, Zulkarnain, do you have a question? So just okay. So just like that, you see, we got the perfect value, 237, which I wanted to demonstrate and write in binary form. So the answer to 237 in binary is 0000 1110 1101. Now this is in 12 bits, right? Because I made use of 12 bits. But just like Zulkarnain mentioned, this could also be written in an 8-bit register. So if I had like 8 bits, so 1 2 3 4 5 6 7 8. So you see, I could have also written it in 8 bits. So 8-bit में इसका आंसर क्या होता? It would have been 1110 1101. So if I count the 1 2 3 4 5 6 7 8, this is 8 bits. And now why would the answer not change? Because if I want to convert this 8-bit into the 12-bit one, I'm just adding these useless zeros, which don't have even any sort of value. So if I had like 0000, this is going to become 12-bit. And if I want to make them 16 bits, I can add other 4 zeros. And now this becomes a 16-bit register. But because we don't want to do that, we just want to keep it efficient. So the answer to this in an 8-bit register would be 1110 1101. Is this clear, guys? We just studied the conversion from a denary number system into binary number system, and we understood how this is basically being implemented. Now, before moving on and ending the class, I want you all to quickly let me know, is this 100% clear, yes or no? If you guys have any questions or you don't get anything, just let me know quickly in the chat box. You don't need to worry at all. Batao, jaldi. Perfect, Samrat. That's great to know. Baki, Saifullah, Inaya, perfect. Rayan, perfect. Zarek, perfect. Ahmed, आप बताओ, Zulkarnain, आप बताओ, is it clear or not? Perfect. That's so great to know. Great to know. Ramin, you tell me, is this clear? Yes or no? Or if you have any questions, okay, can you please answer the question that explain the method to convert the number from binary to binary or vice versa for 4 marks? Ramin, you don't need to worry. Inshallah, tomorrow's class में in tomorrow class we will be doing a past paper question. तो उसके अंदर we would be converting from a denary to a binary, and at the same time we would be also doing binary to denary because we have not studied the other way conversion. So I would not be answering that question at this point. But inshallah, in today's class, we finally understood how if I tell you that you scored 75 out of 80, you guys can now convert that 75 into a language which the computer can understand. So into zeros and ones. So if you want to go and quickly amaze your parents, you can just go and tell them that do you know I now can speak the language of computers. Just give me a number and I can translate it into the language which the computers can get. So yeah, so tomorrow, inshallah, we are going to understand that if I have a specific computer a language term, so like if the computer has a specific binary term, how can I convert that into denary? And we are going to be studying that, and we'll be doing some sort of past paper question alongside that, and you're going to see that this has to be one of the most easiest topic out there. So I hope this is perfectly clear, and that's so great to know that you all are good to go with this topic. With that, it's 10:02 p.m. We would be ending our second demo class at this point. See you guys, inshallah, tomorrow at 9 p.m. Take care. Allah Hafiz. Bye bye. Allah